All right, we're going to focus on expected value, probability distributions, and box and whisker plots. So the review, we've done a weighted average in our last lesson. And what that is it's calculating the mean by using frequencies of data values. For numerical data, the weighted average of all outcomes is called the expected value for an experiment. The probability distribution for an experiment is the function that pairs each outcome with its probability. So here's an example. The probability distribution for the number of games played in each World Series from 1923 to 2004 is given below. Find the expected number of games in a World Series. So this first number says the number of games in the World Series, so if there are 4 games in the World Series, the probability is 5 out of 27. And then we continue looking at our probabilities. So if there are 5 games, then there are a probability of 5 27s. Notice that these fractions will always add to 1 because that would represent 100%. So what you do to find the expected value is you multiply 4 times 5 27s, 5 times 5 27s, 6 times 6 27s, and then 7 times 11 27s. And then you simplify it, and you get the expected number of games in a World Series to be about 5.85 games. Example 2, the probability distribution for successful free throws for practice is given. So to get 0 free throws in a practice, the probability is 3/20. So you multiply 0 times 3/20 plus 1 free throw, and the probability is 3 out of 20. 2 free throws at practice, 1/5. And then 3 free throws is about 50%. And then what you would do is you would multiply those fractions together. So you're going to get 0 and then 3/20 plus 2/5 plus 3/2. Now notice those denominators are not the same. So if we want to change them to all a like denominator, the LCD would be 20. So we need to change 5 and 2 to be a denominator of 20. So 3/20 is there. And then we're going to change that 2/5 to have a denominator of 20. So we multiply the numerator and denominator by 4. And the next fraction, we need to multiply the numerator and denominator by 10. So then we get 3/20 plus 8/20 plus 30/20 is 41/20, which is equal to 2.05 is the average amount of free throws for a person at practice. The next thing is called a box and whisker plot. A box and whisker plot shows the spread of data. It displays 5 key points: the minimum, the maximum, the median, which is in the middle, quartile 1, and quartile 3, which are the medians of the upper half and the lower half. The IQR represents where 50% of the data falls. So the IQR is the distance from Q1 to Q3. That's the IQR. And this is the middle 50% of the data falls there. So example 3, make a box and whisker plot with the data. So here's our data, and what we have to first do is list it from least to greatest. And then we need to find what we call the 5-number summary. These are the 5-number summary, which make up the box and whisker plot. So we first find the median, which if we look at how many data points there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we take 18 plus 1 divided by 2, 19 divided by 2 is 9.5. So you're going to take the 9th and the 10th data points and average them. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So you're going to take the 9th and 10th and find the median. So you get the median, which we also call that quartile 2. And then you identify the smallest number and the largest number. And then we have to find the lower quartile and upper quartile. So we're going to split this in half, and we have to find the middle between these two sides. So then we would work our way to the middle, and we get 4 and 9. So again, Q1 and Q3 are the medians of the upper quartile and the lower quartile. So then what we do is we create a number line. So here's our number line from 0 to 15. And you put dots. This is your minimum. And this was your maximum. And then here's your median, Q2. And here's Q3 and Q1. So there's your 5 data points. Then you create a box around Q1 to Q3, and then you split the box, the rectangle in this case, down the center where that Q2 is. And then lastly, you create your whiskers. Your whiskers go from Q3 to the max and Q1 down the middle. The last thing is to identify the IQR. So we subtract Q3 minus Q1, which is 9 minus 4, giving us 5. All right, let's go ahead and do one together now. We want to create a box and whisker plot for this data set. So let's find the smallest to largest. So 4, 5, 8, 9, 9, 10, 11, 12, 12, 15, 16, 17, and 20. So the minimum is 4. The maximum is 20. Then we want to find the median, Q2. So we add up how many data points there are. There are 13 data points. So we take 13 plus 1 divided by 2. So 14 divided by 2 is 7. So we're going to go to the 7th data entry, which is right here, and we call that Q2. And then we want to find the upper and lower quartile. So we're going to go to the middle. So here's our middle 2 points. And we find that average. So that average would be 8.5. So that's Q1. And then we go to the middle of the upper quartile. And that's going to be 15.5. And that's Q3. So we have 8.5 and 15.5. And then 11. So this is our 5-number summary. Now we're going to go ahead and create our box and whisker plot. So I'm going to identify each value on my number line is 2 units. Okay. Now we start with our numbers. So our minimum was 4 and our maximum was 20. Then we had 11 as our median, and then 8.5 as quartile 1, and 15.5 as quartile 3. So then we create our rectangle from Q1 to Q3. Then we split the rectangle down where the median is. And then our whiskers. And then last thing is to identify the IQR. So the IQR is going to be quartile 3 minus quartile 1 value, which is 15.5 minus 8.5, which is 7.